Geometry checkpoint 6, solving proportional equations and similar figures. A proportion is an equation stating that two ratios are equal. To solve a proportion, begin by eliminating the fractions. Multiply the top of the first by the bottom of the second, and the bottom of the first times the top of the second. We sometimes call this cross-multiplying. Then solve the resulting equation in the usual way. Remember, to solve problems with similar triangles, the corresponding sides must be consistently used in the ratios. So for my first one, we're going to start off nice and easy. So again, we're going to multiply the bottom of the first times the top of the second, and the top of the first times the bottom of the second. And I'm just going to write this out. So I've got x plus 1, and I'm going to put it in parentheses, times 3, and that's going to be equal to x times 5. And again, we're just multiplying them. So now I'm going to need to distribute. So x times 3 will give me 3x. And 1 times 3 is going to give me 3. On the other side, I've got 5 times x, which is 5x. So we're going to solve now in the usual way. So the first thing we need to do is get our variable by itself. In this instance, I'm actually going to put the variable on the right-hand side just to make it a little easier. So I'm going to subtract 3x from both sides. My 3x minus 3x cancels each other out, leaving me with just 3. My 5x minus 3x gives me 2x. So now I'm going to divide both sides by 2. 3 divided by 2 gives me 1.5. My 2's cancel, leaving me with x. Now I'm sure some of you are already going, oh no, we've gotten a fraction, we must have done something wrong. So let's go back and test and see if we actually made any errors. So I'm going to take 1.5 and plug it in. So I've got 1.5 over 1.5 plus 1, and we want to see if that's equal to 3/5. So 1.5 plus 1 gives me 2.5. Now, most of you are probably going to verify this on a calculator, doing 1.5 divided by 2.5. I don't have a calculator with me right now, but I do realize that if I multiplied 1.5 by 2, I get 3. And if I multiplied 2.5 by 2, I get 5. So these are, in fact, equal ratios. So I didn't make a mistake. So I'm going to go ahead and put a box around my answer and put a little check mark. Now for my next example, we're solving for the missing side, which in this case is going to be DC. So what you have to be very, very careful about when you're solving for similar figures using missing sides is you have to make sure you match everything up properly. So for instance, right here in the middle, I've got a pair of vertical angles. Since those angles are equal, those sides are the ones that are going to go together. So I've got 10 and 6. So I'm going to put 10 over 6. Now, most of you are probably saying, okay, it's going to be equal to 6 over x. But just so you understand why, because in some of the examples, you're going to have sides here as well. Remember, these two arrows mean that the lines are parallel. So when I've got two parallel lines cut by a transversal, I know that this angle here is congruent to this alternate angle here, which means that this side of 6 goes with this side of x. Again, you need to be consistent. Since I put 10, which is on my left triangle, over 6 on my right triangle, I need to put my left triangle of 6 over my right triangle of x. So now we're going to do the same thing. We're going to cross multiply and solve. So I've got 6 times 6 on the left and 10 times x on the right. 6 times 6 is going to give me 36. 10 times x is going to give me 10x. So now to solve for x, I'm just going to divide both sides by 36. And again, I get a decimal of 3.6. Now for this one, I will plug it back in, and I'm going to have to cross multiply. Or you can pull up your calculator, and I'm going to use the one that comes with the computer. So I've got 10 divided by 6, which gives me 1.66666 repeating. And then I've got 6 divided by 3.6, which which gives me the same number. So I did in fact do it right. Move the box and a check mark to show my teacher that I remembered to check my work, and move on to the next problem. Again, if you have any questions, feel free to email me at mbrener@d131.org.